Alright, so we're in chapter 5. Alright, so last time we talked about the rules of antiderivative. So you are going to have to switch gears here in chapter 5. We're working backwards, working in reverse. So this is when we learned the derivatives forwards, and now we're learning the derivatives backwards. And so, like I said, you are going to have to sort of switch gears here mentally and work backwards from your derivative rules. Alright, so remember, this is the integral symbol. Alright, so this integration means I want to find the antiderivative of this function with respect to x. I want to find the family. This is the indefinite integral. Indefinite means it's unknown, right? Because c could be anything. That's what the indefinite part is. Alright, before I get started, I am going to change things a little bit. I have to change this function, and I'm going to rewrite this one just to remind you what it is. You don't have to do that step, but I am just to kind of show you what that is. Alright, so I want to find the antiderivative. The 3x to the 5th is fine. I'm going to pull the 2 out front and rewrite it as, again, 2 divided by x is the same as 2 times 1 over x. And that's just to remind you what the antiderivative of that function I'm looking for is. Square root of x, just like when I take derivatives, I have to change that to the half power. Alright, and so I'm undoing the derivative with respect to x. Alright, so I want to find the function, all possible functions that give me this derivative, right? That's what the antiderivative is asking you to find. What are all possible functions that have this expression as its derivative? Well, I've got to undo all my derivative rules. Alright, so the power rule, this is a special rule, right? The derivative of 1 over x is our logarithm. Power rule, power rule. Alright, so 3 power rules and a logarithmic rule. Alright, so 3x to the 5th, right? Remember, I add 1 and divide by that expression. So it's the exact opposite of the derivative in the exact opposite order. I add to my power and divide by that number. Alright, the next expression, the negative 2, is a constant multiplier. It comes along. The function that gave me out the derivative 1 over x was the natural log. Now, I don't want to have to say only for x values bigger than 0. So to get around that, we always tack on it's the absolute value of x, and then I'm good. That works for all x values that were in my original expression. Alright, the next one is my half power. Remember, we add instead of subtract because it's antiderivative, so we're adding. So I get 1/2 plus 1, no, that's 3/2. Well, instead of dividing by 3/2 and getting an improper fraction, well, instead of dividing by a fraction, well, that's the same as multiplying by the reciprocal of the fraction. And so that's what I'm going to do. I'm going to, instead of dividing by 3/2, I'm going to multiply by 2/3. It's exactly the same thing, right? Division is the same as multiply by the reciprocal, and with fractions, we always want to do that. Alright, and then the negative 4x, so negative 4 comes along, that's a 1, add 1 to 1, give me a squared over 2. And then don't forget, I want all of the possible functions that give me out that derivative, and so there needs to be a plus c. You should always write your answer in simplified form, which means reduce any fractions that you can. I can reduce this 3 over 6 to 1/2. ln stays negative 2 times the absolute value of x. And then 2 divides into 4 and gives me 2x squared plus c. This is my family of a function that represents the family of antiderivatives. If I take the derivative of this, it will equal my original expression. All right. Next example. All right, the next example I have to do a little work before I get started, right? There's a multiplication here. Now, there technically is a product rule. It's in chapter 6.1. But because we have to cut stuff out, we're going to cut that out. So we're not going to go over the product rule. It's called integration by parts. And so whenever we're given a product, we should be able to manipulate it. And this is a product, right? I've got this 2x times that expression. Well, we don't have, and we're not going to go over a product rule. And so I have to undo the product. So, well, I have to multiply that through to get rid of the product. All right, so I'm going to multiply through, distribute that 2x. And so when I do, so it'll be 2 times x. When I multiply, I add my power, so 1 plus negative 4 will give me a negative 3 power. 2 times 5 is 10, x to the 2nd. minus 2x to the first. All right. There is my function where I've gotten rid of the multiplication, right? Because I don't have an antiderivative for multiplication. I don't have a product rule. And then we won't in chapter 5. And so I now can use my power rules. All right, so my family of antiderivatives, well, my first one is my power rule. 2 comes along. Add 1. So remember, I have negative 3 plus 1, so that's going to come out negative 2. Divide by that negative 2. 10, x raised to the plus 1, 3. Divide by that 3. X raised to the second, divide by that 2. And then don't forget, I want all of them, so there's that c I have to tack on at the end. And then simplify this. Always write your answer in reduced form. Now you can leave the negative power. That's fine, but this does reduce to negative 1 x to the negative second. That one doesn't. Stays 10/3. That 2 reduces to negative x squared plus c. And there is my family of antiderivatives. Now just be aware, if you are practicing the connect problems, they will rewrite this as negative 1 over x squared. So that's when you're doing the online stuff. But for my homework and test, you can leave it negative 2. Alright, the next example. So now I've got my e term, e to the 0.2x. Alright, so this would be an exponential growth function. 1 over x cubed plus 8. There is no quotient rule. We will never have a quotient rule. And so whenever there's a division, I should be able to manipulate it. Alright, so I'm going to rewrite my e term because it's just coming along. But I'm rewriting that function. Alright, I can't take an antiderivative of 1 over x cubed. Alright, I've got to rewrite it as x to the negative third, then the 8 comes along. Alright, now I can take my antiderivative. Alright, so my family of functions, when I take the derivative, I get this expression out. Alright, that's what I'm looking for, right? Antiderivatives are looking for all possible functions that have that as a derivative. Alright, well, the e rule is itself 3e to the 0.2, but remember, because there was something other than x, when I took the derivative, I would have multiplied by that. When I want to undo the derivative, I have to divide by that number. Alright, so that k value up there, I have to divide by it. Alright, the next term is I'm adding 1, so it's going to be negative 2, and then I divide by that negative 2, and then constant rule. Alright, 8x plus some constant. Don't leave it like this. This is improper. Alright, so don't leave 3 divided by the decimal, divided by that 0.2. That's improper. You have a calculator, you can simplify that with your calculator. Take 3 divided by 0.2, or that's 1/5. So instead of dividing by 1/5, you can multiply by 5. It should come out 15 e to the 0.2x plus, right, the negatives cancel, 1/2 x to the negative 2, or if you rewrite that, it'd be 1 over 2x squared. All right, and there is the function. They're all possible functions because it's plus c. When I take its derivative, all right, I get that expression out. All right, the next one for some reason didn't come down, so I'll give you a second while I write it down. It was 40e to the negative 0.1x plus 5 over x minus 3x squared plus 1. Alright, that's the function that should be in your notes. Alright, so I want to find the family. I don't have to rewrite anything because remember, this really is 5 times 1 over x. So this is my logarithm rule, right? This is my e rule, power rule, constant rule. Alright, so my e rule first. So I write down the 40e to that negative 0.1x, but I'm not done yet. Because when I took the derivative, I would have multiplied by that negative 0.1. Well, I want to do the opposite, so I'm going to divide by that k value, that negative 0.1. And then this is our logarithm rule. 5 is just a constant multiplier, right? This is the same as 5 times 1 over x. And so it's 5 times the natural log. Remember, absolute value of x, because I don't want to have to state if x is bigger than 0. I want it for all x. Alright, then the next one's just the power rule, 3x squared, so x cubed divided by 3, and then x. Don't forget the plus c at the end. And then clean this up. Don't leave this. This is improper. Don't leave it. This is improper. Don't leave it. And so the family of antiderivatives, well, again, you could take the calculator out, take 40 divided by negative 0.1, or negative 0.1 is negative 1/10. You take 40 times the reciprocal of 1/10, which is times negative 10. So you get negative 400 e to the negative 0.1x plus 5 times the natural log of the absolute value of x. Don't forget your absolute value. The 3's reduce. Leave me with x cubed plus x plus some unknown c. And so there is my indefinite integral. There's the function. When I take its derivative, it gives me out that original expression. Alright, the next example. Alright, so this one I'm going to do some rewriting. I'm going to rewrite this function, and I'm going to rewrite this function. And where I don't want you guys, some reason students will get confused. This is x cubed, which is different than the previous one where it was 5 over x, right? Here was 5 over just x, and so that's the natural log rule. This isn't over just x. This is not the natural log rule. It's 12 over x cubed, and I rewrite that as x to the negative third. All right, so before I get started, I'm going to rewrite this as its fractional power x to the 3/4. That one I'm going to rewrite as 12 raised to the negative third. That one's already a half power. That would have been the square root function. And then I had the e to the x. Alright, now I'm ready to find my family of antiderivatives. Alright, so I add 1 to the 3/4. I'm going to add 4 over 4. So I'm going to get 7/4. And instead of dividing by 7/4 and giving myself an improper fraction, I'm going to multiply by the reciprocal. Alright, so the reciprocal of 7/4 is 4/7. Alright, and that's what I'm going to multiply by because I want that to undo that when I multiply it out. Alright, the next one, negative 12 comes along. I add 1 to the negative 3 to get negative 2. Divide by the negative 2. 1/2, I add 1 to get 3/2. And again, same thing. Instead of dividing by it, I'm going to multiply by 2/3. Antiderivative of e to the x is e to the x. And then don't forget the unknown constant. That's what makes it the indefinite. This is the indefinite part. Because c could be anything. Alright, clean it up. This is the only part that really needs to be cleaned up. The rest of it's fine. Alright, I could take 2 and divide it into 12 to get positive 6. X to the negative 2. And there's my function. My family of antiderivatives. Alright, my function. Alright, the last one for this set of notes. Alright, so again, there is no quotient rule. Whereas there is technically a product rule, we're not going to get to it. There is no quotient rule, which means when I have a division, I should be able to manipulate it, or it's a special case that involves a logarithm. Alright, so this one I'm going to manipulate. And I'm going to manipulate it by splitting it into two little fractions. Alright, 1 over x to the 4th minus 2x squared divided by x to the 4th. And then rewrite this as x to the negative 4th. Remember, I subtract my exponents, 2 minus 4, so that'll give me 2x to the negative 2nd. And now I'm ready to use my power rules. Alright, those two functions are the same. If I graphed this original function, it'd be the exact same as this original, or this function that I've rewritten. Alright, the rules, power rules on this case. So x raised to, I'm adding 1. So I'm going to get negative 3 divided by negative 3 minus 2x raised to the negative 1 divided by negative 1 plus some unknown constant. And again, it's fine if you leave it with the negative exponents. Or, like I said, if you're doing this in Connect, they will rewrite this. They'll move those underneath where they're supposed to be and leave them without the negative exponent. So this would be rewritten as 1 over 3x cubed, 2 over x to the 1st plus c. Alright, so just be aware of that. Again, I'm fine with either expression, but on the Connect math, they will rewrite it. So just be aware of that when you're working through the Connect math. Alright, so that finishes up this particular video. And again, it's just kind of changing your mindset. Working backwards. Alright, so you just have to get used to, I'm undoing the derivative, so I've got to do it in reverse. Alright, undo it to get back to my original expression. Alright, the next thing we're going to do is applications, alright, of the indefinite integral called initial value problems, and that'll be the next set of notes. So we'll stop there.